This video is going to explain the awesome question of why does it rain? Why are clouds formed where they are? It's an important concept. We're going to end up drawing this 3 different times, 3 different videos, basically drawing the same diagram but showing different things. But it's fundamentally this same diagram. That's why it's really important to understand this one. So we're going to start. So get your paper out here. We're going to start with just drawing the ground. Hope you like my new little whiteboard here. Getting used to it. And as with a lot of things in apes, a lot of things are responsible, or what's responsible for a lot of things is the unequal heating of the earth. As you're going to hear that term a lot. And so here's some sunlight. And it's heating this one portion of the ground. So if the ground gets hot, then it absorbs some of that sunlight. It gets hot and it heats the air around it. So if this air right here is 25 degrees Celsius, so that's a pretty comfortable day, the air right here might be, and we're just going to draw this as a little bubble of air, this air right here might be 30 degrees Celsius. Now, why is this air a different temperature? This could be cloudy here, but it's a pocket of sunlight here. We're going to see some examples of when that happened. But this air is hotter than this air. So what happens when anything gets heated? Especially gases, when they get heated, they expand, right? So if they expand, that means they're less dense than everything around it. If things are less dense than what's around them, they're going to become buoyant and they're going to rise, right? So let's draw that. So it's going to rise. So this air is heated, right? The heated air expands, becoming less dense, all right? And if it's less dense, what's going to happen? It's going to rise. All right, so I think we know that. Hot air rises. See that in hot air balloons and everything. But this is the key, all right? When it goes up, just to review what we just learned in Chapter 4, what happens to the atmosphere as you go up? Well, it gets colder, that's true. But one of the other things is that the pressure is reduced. So you have less air pressure because it's like if you're at the bottom of a swimming pool and you start coming up, there's just less water above you. Now there's less air above you, so there's less pressure. And what happens is that because there's less pressure on this bubble of gas as it comes up, it's going to expand more because there's less pushing down on it. It's staying at this size right here because there's pressure, there's equal pressure pushing on both sides. But as it comes up here, this arrow gets a little smaller. So this gas bubble here, as it rises, it's going to expand more. All right. So the air pressure is less, right? As you go up, the air pressure is less. So air continues to expand. It's going to continue to expand. Okay, it's getting, and this is an important concept, although it's not easy to explain why, so I'm not going to do it. But you understand it because if you ever used a can of aerosol, hairspray, compressed air, or spray can of paint, what happens when to the can, the temperature of the can while you're spraying it? It gets colder, right? The reason why it gets colder is that as things expand, they cool off. If everything else is kept the same, something that's expanding cools, especially gases. So because of this expansion, the temperature of this gas now is less, and it needs 20 degrees. And this is important because what do we know about colder air? As air gets colder and colder, can it hold more water or less water? It can hold less water. Although it's the same amount of water in the air, because it can hold less water, it's like the cup is getting smaller and smaller. So the fullness is getting more and more. So what happens to the RH? So relative humidity, and this is key, I'm going to put this in blue here. As the air cools, the RH goes up. right? As air cools. As air cools. Colder air cannot hold as much water as warmer air, so that the relative humidity goes up. Sometimes the air pressure would stabilize right about here, but if it's still a little bit less dense than the air around it, it's going to continually move up. Okay, it continues to go up. And I think you can see as it continues to go up, it's going to continually pass through air that's of less, decreasing pressure. So it's going to continually expand. If it's expanding, it's going to get colder, and it keeps on getting colder. And so if the relative humidity is getting higher and higher, if down here, if it was 50% humidity, and now it's 60, 70, 80, 90, at some point you're going to hit this mark, which we're going to put as a dotted line here. And this is the condensation point. That's the point at which the air is saturated. And if it cools anymore, the water's got to come out. And so it comes out in the form of a cloud. It doesn't rain, because rain is falling water. This is a cloud. This is liquid water. It's just tiny little droplets. They condense on little particles of dust or smoke or pollen. And then when they coalesce and get bigger and bigger and heavier, then you're going to get some rain. All right. So there's many different things you can call this. You call this the condensation point. You can also call this the dew point. You can call it the saturation point. But it all means when the RH equals 100%. Right? When the RH is 100%, you get to that condensation point. And so the big takeaway about this is that when you have rising air, it gets colder and colder until you make a cloud. It's going to happen every time. Rising air makes clouds. So this whole process of rising air making clouds is called adiabatic cooling. Fancy word, but it's nice to have a word like eutrophic, where we don't have to talk about all this. We can just say adiabatic cooling. That means when air is going up, it's going to expand, it's going to cool, the relative humidity is going to go up, and we're going to eventually get rain. This is adiabatic cooling. I hope that's understandable. The one last thing I want to add to this is what happens when, let's just say, how is this air different? Well, this air over here now has lost a lot of moisture. What happens if this air starts falling? Right? So if air is falling, let's say falling air, right? This is rising air. Right? So rising air makes adiabatic cooling. If you have falling air, the pressure gets more and more and more, right? Greater and greater and greater. So instead of expanding, you're going to get air contracts, right? Air is going to contract. As it contracts, it's going to get hotter, because that's the opposite. Everything is opposite. It gets hotter. And what's going to happen to the RH? The RH, everything is opposite. The RH is going to go down, right? So this whole process in reverse is not called adiabatic cooling. This is adiabatic heating. And it's exactly the same process, but it's going this way. There you have it. That's adiabatic cooling, adiabatic heating. Very important. We're going to see it twice more in the next 2 videos.